seems like everybody has done a video on Nvidia buying ARM, and the one thing that I haven't seen anywhere, it's probably because I'm a little crazy person and or this is a level 1 ramble, is that it seems like it's a good idea. I mean, a lot of ARM employees seem like they're on board with it, and I've seen a lot of people and a lot of analysts say, hey, you know, this ARM Nvidia thing, the co-founder of ARM said, no, we have to stop this, we have to keep jobs here. I don't see it really as that bad. It's actually, my first instinct was, this is probably a good thing for both companies. It's a great thing for ARM employees, and it's probably a good thing for Nvidia. Now, did Nvidia need ARM specifically? No, but Nvidia did need some kind of a processor company. I mean, with Nvidia's resources, ARM could upend the entire x86 ecosystem. And if that happens, Intel had better pray that AMD has got some killer performance up their sleeves, or x86 could be eroded away much sooner than expected, because you know, what a thought that is. It's like Intel is depending on AMD to keep ARM at bay because the ARM products with Nvidia's resources will be superior. That may be what we're facing here. For ARM and this sale, ARM has to know that they were in danger of becoming another MIPS, because RISC-V is about to eat their lunch at the low end. RISC-V is a great approach. It's a great way of dealing with it. It's great all around. There's something in thinking through all this that I keep coming back to, and it's like, how am I going to explain this in a way that makes sense? Because my brain is like messed up, and I think visually, and so sometimes I say the wrong words for things, not meaning to, and so it sounds really silly. But I want to introduce the concept of baggage to you. Baggage is when you're encumbered by bringing stuff along with you that you didn't really need. A great example of this is smartphones. Remember Windows Phone? Like, smartphone was starting to take off. Windows Phone, it's like, I can have Windows applications on my phone. This is great. It's so powerful. It's so insane. They put the start menu on a phone. Like, you would have to whip out the stylus and then hit the start button. And why? Anybody with brain one would look at that and look at the user experience of that and say, this is really dumb. Who would want a start button on their phone? That doesn't even make sense. Like, you look at it, you try to use it, it's clumsy and terrible, and like, it's so obvious that it's bad. It was like, I was going around when it was first, out. It's like, is this really a thing? Are we doing this? This seems really dumb. And people treated me like I was a crazy person, because it was like, no, it's the start menu. This is the most successful idea in user interface paradigms ever. That's baggage. And ultimately, that was dumb. There isn't a phone today that has a start menu type button or something that works kind of similar to that. I mean, the Android launcher maybe, but arguably also not a great example of user experience. Baggage kills innovation. So what about x86 phones? Why don't we have x86 phones? Why is ARM more popular in phones? Well, Qualcomm did some shenanigans in the beginning, but also x86 is too bloated for phones. Do we really need a phone that can run Lotus 123 for DOS? I mean, that's what you get with x86. You get backward compatibility all the way back to the beginning of time with some stars and asterisks and compatibility there. I mean, the philosophy of ARM is to have a relatively limited instruction set. It's literally a reduced instruction set, and you make up for the lack of physical hardware that you have in software. The compiler and other software tools will take your program and sort of simplify it. On the x86 side, we try to do as much as we possibly can in an instruction. I suppose philosophically, the system designers looking at this and saying, okay, the speed of light is finite. The speed of electrons through silicon is finite. Our clock speed is finite. We need to do as much as we possibly can every clock speed in order to get the maximum possible performance out of this CPU. And on the ARM side, it's, keep it simple, stupid. And it seems like right now, today, with where we are, keep it simple, stupid is winning because of security and a whole bunch of other stuff that I'm going to talk about. But it is there's not one approach that you can definitively say, yes, this is absolutely better in all cases. ARM, because of its reduced complexity, also means that it's much more power frugal. x86 needs a lot more transistors. A lot more transistors is power hungry. So you can do stuff to try to mitigate the power usage, but again, in a phone, ARM, pretty good. And Intel did, this is the Zenfone 2. This is x86 in a phone. You could do a lot of cool stuff having the same processor in your phone, and your laptop, and your desktop. I'll give you a freebie. Virtual machines. So this is kind of far out there, and you'll say, this sounds kind of weird, but mark my words, Apple's going to do this when they get, ARM everywhere. I'm running an application on my phone. It's in a virtual machine sandbox. I just move the running application in its current state to my laptop or my desktop. So I can work on my desktop, then move to my laptop, and then move somewhere else. Some cell phones do this. The docks where you plug your cell phone into a dock and it becomes a laptop, those were marginally popular because the horsepower of the phone was sufficient that you could get a laptop-like experience running Chrome OS or Android. But the software really wasn't there yet. And it's harder to do that kind of an experience cross-platform unless your software interface, your APIs and stuff are really robust. And I don't think we're there yet and on the software side of it. But if you had x86 on your phone and your desktop and your laptop and all across all of your products, from a developer integration standpoint and from you having your own internal staff to support all these things do actually become a lot easier and a lot simpler, and you can provide better tools for developers that want to leverage your platform to do stuff. But Apple never could get a sufficiently low power x86 processor that could even compete with the ARM offerings, and so the rest is kind of history. There wasn't really anybody inside Intel that was saying, hey, x86 on a phone, we don't really need all this old stuff. I mean, we can kind of sort of leave it there, but let's do something different that's targeted specifically at phones. Because the power utilization just never materialized. Even though Intel should have had better processes, like better technical and hardware processes to be able to do those cool things with phone processors, but it never materialized. So what about ARM and Nvidia? Does that mean that Nvidia is immediately moving into the mobile games? Like, well, no, I don't think so. Nvidia isn't as interested in mobile yet. Certainly there's applications for machine learning and some of their GPU smarts, but the first thing for Nvidia is going to be the data center. All of the money from Nvidia's meteoric rise is from machine learning and stuff that's going on in the data center. I mean, their market cap is past Intel's. Think about that. Think about all of the stuff that's going on with big data and machine learning. And that's, where Nvidia has gotten their cash. Their GPUs are just, the cornerstone of these machine learning appliances. They want to build a brain in a box, and the CPU doesn't really matter too much. They just need to be able to do stuff with the GPUs. And that's it. You already know that. I mean, how many builds have, tech YouTubers done where it's like, let's take this Xeon from 2006 and pair it with a 2080 Ti, and look at that. The performance is 98% as good as it is if you get a modern 6-core processor, because, when the GPU is doing all the work, CPU doesn't really matter all that much. Did it have to be ARM for Nvidia? No, it could have been anything. But ARM is particularly interesting because they have a better ecosystem of tools, developer tools, and customers using the ARM intellectual property in creative and interesting ways. And so ARM has a lot of institutional knowledge about how their products are being used across a wide ecosystem, and that knowledge is kind of unique. But in terms of we need a processor, Nvidia could have used pretty much anything. This sale makes sense for SoftBank too, because I think SoftBank overpaid for ARM when they bought it. That's just how it is. And they were probably scared to death of ARM becoming the next MIPS. So if you're not hip to MIPS, history always repeats itself. MIPS was the reduced instruction set platform of the 90s. So many brilliant ideas, so many academic works and textbooks, and it was literally everywhere. Digital Equipment Corporation had a lot of the ideas and stuff from MIPS were borrowed into the DEC Alpha, the Digital Equipment Corporation Alpha, and that CPU was Alpha. It was Alpha AF. And in fact, if you've got an Alpha system that you want to send me for my collection, let me know, because that's the one thing that I don't have, like a full running system. I've got the CPU, but Alphas were nice. Unix systems, solid, fast, expensive, very, very expensive. If they had been dirt cheap, they probably would have taken over the universe. But yeah, MIPS, it was taught everywhere. It was, it still is taught everywhere. But there's still a lot of devices that are being made with MIPS. If you take phones out of the equation, MIPS is probably still one of the top CPUs deployed everywhere. Everything from access points to industrial control systems, traffic lights. A lot of infrastructure runs on MIPS CPUs, but it's a little bit dead zero walking. One of the things that's making all of this a little weird right now is all of the security stuff with microprocessors. All of those shortcuts and optimizations and everything that went into making computers in general faster, it's just now apparently occurred to us to weaponize those shortcuts. So, Intel, I mean, they're the unquestionable world leader in microprocessors. They seem to have been blindsided by exploits like Spectre and Meltdown. I mean, their microarchitecture is dated. It hasn't kept up with the state of the art in, the tooling that's available and the latest ideas in information theory and security. I mean, the number of flaws and mitigations is really high, and that kills performance, and all that baggage is breeding complexity. And that's too much to ask of lowly developers that are working on these systems. And Intel being the world leader, you would think that they would have been on top of these kinds of things, seen them coming from a mile away, and invented new computer science to deal with them. And that hasn't been the case, which is very surprising given Intel's market position over the last 50 years. And now since 2017, AMD comes along with Zen, and they've got a lighter, faster x86. I mean, it's got features like memory encryption, which is, thwarted a lot of these side channel type attacks. Not everything. There's still some flaws here that AMD processors are vulnerable to, but in general, AMD's weathered that storm a lot better than Intel, even through successive new processors from Intel over the last 3 years. If you go back a little bit, I love this article from the Motley Fool in 2018. Has Intel given up on the PC? Intel's keynote at Computex in 2018, I kid you not, was not really about PCs. It was about Intel diversifying. And the message from Computex then was basically like, oh, we've hit a wall. We're going to work on AI, and we're going to work on this, and we're going to work on all this other stuff. They were showing off Nirvana, which they'd actually acquired in 2016. It's like, look at the neural learning thing. We've got self-driving vans. We've got all this really awesome stuff. And they did even show off that now infamous 28-core, 5 gigahertz Xeon CPU, which I have one of, and it's not going to hit 5 gigahertz unless you're running liquid nitrogen or a chiller. And all of the other stuff that Intel showed off in 2018, like Nirvana, pretty much all of that has been a dead-end technology, or at the very least a technology that hasn't been as useful monetarily as you might think. I mean, Intel being the giant company that they are, it's like, oh, we made $3 million on that. It's like, yeah, but I mean, if you just bought the cheaper toilet paper for the executive toilets, you'd probably save $3 million a year. So, I mean, that sounds like a lot, but you really, was that worth your time? I mean, shouldn't you be working on some of the other stuff? It's good to diversify, but something's not right. From my read of it, they seem to be saying, we're doing okay in CPUs, but we're going to enter kind of a dark time. We need to diversify a little bit. Okay. The physics of the processes and stuff have gotten really complicated, and we're just going to have to work on this other stuff. Okay. But then along comes plucky little AMD and TSMC and Samsung, and and it's like, oh, I mean, since then, Intel has got a new CEO, and they've had some shakeups in their manufacturing departments. So, leading edge manufacturing isn't enough. Vendors have to build the ecosystem, and Nvidia wants a turnkey, brain-in-a-box for a data center, and that's the first thing they're going to do, and that will deliver the overall experience. And I think that's what's missing on the PC industry side. And Apple is kind of trying to do that. I mean, to give credit where credit's due, Apple is kind of trying to do that. That's part of MIPS's problem, too. It's like the software tooling doesn't exist. Things like address space layout randomization, that's something that showed up in Windows, I think, in like 2003. Maybe even a little before then. And it didn't come to Linux on MIPS until like 2016. There weren't really any customers that wanted it or need it. And address space layout randomization is like one of the first defenses against exploits and attacks and the kinds of things that you run into, in an environment where you need at least some security hardening, and it's not there. ARM is not yet suffering from those issues as badly because, one, of its current popularity, but two, it's also in high margin, high profile devices, things like phones. And things like traffic controllers or wireless access points perhaps are a bit less high profile, at least until something crazy happens, than a mobile phone. but these are also not issues that can be fixed really quickly. These are not really issues that can be fixed really quickly with ARM CPUs, and there are flaws in things like embedded GPUs, like the Mali GPU. There have been security issues for it that are more or less problematic to fix. So this is not something that's limited to x86, but it seems to be worse in x86 because of the baggage and spiraling complexity. It's sort of the point that I'm trying to make there. So if ARM is coming, and it is going to be a threat to regular desktop computing, I think it's going to be a threat to desktop computing in the sense that it's going to be in phones and tablets, and those devices will morph back into things that we will recognize as laptops and desktops. Certainly something that's not helping that erosion is you see Intel doing things like maybe playing games with the math kernel library, so that if you use Intel's math kernel library, that library will run badly on competitor CPUs, but it will run okay on Intel CPUs. Nobody's got time for that. Ultimately, that does a disservice to the whole x86 ecosystem. I mean, yeah, you're going to have, your competitors might benefit because you did some optimizations in your compiler or your math kernel library, but these kind of shenanigans will lead to the downfall of x86 in general for everybody. ARM will just take over, or because x86 is so behind in terms of the available optimizations in the industry, it will be supplanted for general use. And it's like, is x86 going away? No, I'm not saying that x86 is going away, but the money gravy train that x86 has been for the last 50 or 60 years would be dramatically reduced. I mean, if you look at the number of phones that are deployed, and it's like, oh, every single one of those could have x86 intellectual property in it. That was money on the table. Like, those horses have already escaped. And here may be the beginning of an inflection point in the computing industry in general. Now is not the time to worry about if you've got 87% market share or 99% market share. Now is the time to make the x86 computing experience so amazing, single thread performance, multi-thread performance. Otherwise, it's going to be very bad in terms of x86 continuing to exist. So in the interlude here, Intel had better hope that AMD has got some killer stuff up their sleeve with x86. Otherwise, x86 is going to be in irretrievable decline, I suspect. We hear murmurs about Intel going to some kind of, big dot little, mixing fast, powerful cores with smaller cores designed for extremely low power usage. This is kind of what Apple does. When you go to an iPad and you turn your iPad on and it's been off for a few days and the battery life hasn't really gone down much, and yet it's downloaded all of your email or all of your data. It's perfectly in sync. And it's like, what black magic is this? It's basically big dot little. And rumor has it Intel is working on that, but big dot little's not enough. I mean, it's not that ARM has the best performance or that ARM or that AMD is in danger of overtaking Intel for the best performance, but that ecosystem and the baggage and all the stuff that goes with that is the part that's missing. I'll give you another great example, Connected Standby. Remember Connected Standby? This was a big feature Microsoft touted on their Surfaces. Intel and Microsoft got together, and Microsoft, the Surface Pro 3, I think, was the thinnest x86 device ever. It was impossibly thin, and Intel and Microsoft collaborated, and it was just this insane device. And the Surface Pro 3 was exciting and insane and really amazing. One of the things they touted was Connected Standby. So the device is going to be on standby. It's not going to use any power, but it'll wake up periodically and download your email or be in low power mode and do stuff and sort of figure that out. And that requires a combination of hardware and software in order to get it done. Surface Pro 3, we're like 6 generations past that on Surface products. And not really, but at least 3 or 4 generations past that on Surface products. And Connected Standby, or the equivalent functionality, is basically trash. People want to be able to go to their tablet and turn it on after it hasn't been on charge for a few days, have the battery not be dead, and have their data. And that experience is still abysmal in the Windows ecosystem. There's just no way around it. And I don't care if it's Microsoft's fault. I don't care if it's Intel's fault. Will big dot little make that problem go away? No, big dot little is not going to make that problem go away. It might go away another year or two after that, assuming that it stabilizes. But I have a feeling that's probably not the case. It's probably going to be like, these products support big dot little and these other products don't. And the software ecosystem to kind of figure that out and work with that it's not going to be there, and so it's not going to be well supported. Kind of like how AVX 512 has been. AVX 512 in the data center, it's like, look what your server CPUs can do. For software that uses it, it's great. Not a lot of software uses it. Does AVX 512 make sense in laptops? I don't think so. I don't think it does. It can in some scenarios, but the software and the rest of the ecosystem just isn't there. And so the work that we did in server has added baggage that's not really helping us on mobile. Not a great situation to be an end user experiencing these things. Most customers want portable computing, really powerful portable computing devices with a good battery life that keep your data in sync and that are, going to handle the various tasks. It should never be the case that an iPad running an ARM processor is a better 4K video experience, 4K video editing experience, than a laptop running the latest 10th or 11th generation Intel CPU. And I realize that whatever is making the experience better on the iPad than the Intel-based laptop may not be hardware. It may be software. It may be, it's like, oh, we're using the Adobe suite, or DaVinci Resolve, or something needs some kind of optimization. Look, DaVinci and Adobe employ smart developers. If they can't figure it out, something is wrong with the tool chain or the ecosystem that is making their lives too difficult. If they use the wrong math kernel library and it doesn't recognize the CPU, and so then it runs in 386 mode, that's not their fault. That is the fault of the people that developed those things. Probably on the Intel side, probably on the Microsoft side, probably on the Apple side, because if we talk about an Apple laptop and an Apple iPad, it's still a better experience editing that 4K video on the iPad side. And you might say, oh, well, the iPad has hardware acceleration built in. The Intel CPU has a built-in GPU. I know we've got Intel Xe, but again, this is harming the x86 ecosystem, is making it ripe for disruption on the ARM side. I do see initiatives coming out of Intel like Project Athena, like a laptop should have this and this and this, and this should be your experience. But again, I go back to the connected standby thing. It's obvious that millions of dollars has been poured into connected standby on the Surface since the Surface Pro 3 and through today, and yet the connected standby experience still isn't great. It's definitely better than it was, but being able to turn a Surface laptop on, or the Surface tablet, and is it up to date? Did it already download everything? Is the battery life still reasonable? No, you still go through the regular old PC boot up process, and it still just takes forever. Or if it is the fast turn on process, the battery's basically dead because it'll only last a day or two like that. That's crazy. The product team has lost the plot. And finally, the other thing that I think means that ARM didn't really have a choice is because RISC-V is coming for them, like I mentioned, at the lower end. Now, RISC-V is already better than the MIPS alternatives in those low-end devices. In a lot of cases, it's really the reason why is the lack of baggage and the tooling for RISC-V is so good. Like the RISC-V marketplace and the way that they're set up to do their, mix and match their intellectual property, it is going to let companies have all of their institutional knowledge in one place, but without the baggage. And so, of course, that's going to be a winning product. I mean, how could it not? So RISC-V is devouring that low end of the market, and that's a pretty reasonable cash cow for ARM historically, but it's going away because RISC-V. And so ARM being kind of trapped in the middle, they have to partner with somebody like Nvidia, or in this case, go to work for Nvidia. So with Nvidia's ARM acquisition, they're poised to immediately do what they need to do in the data center and make a ton of money. But they're also poised to disrupt x86 and desktop processors in general if they want to. I mean, Apple is going to do that with their products, but I mean, with the margins that Apple charges, it's always going to be a niche product. But if ARM, if Nvidia and ARM want to do something on their own, maybe in partnership with Microsoft abandons the Qualcomm Snapdragon version of ARM and goes with some sort of high-performance Nvidia version of ARM, it could happen. Then we may start to see things get really interesting for x86 in this space. So that's why I say I hope that AMD has got something really amazing lined up. I mean, they're just a boring execution machine. They're killing it. And if they can keep things fast and interesting and bring some of these features to the desktop, then it may keep x86 relevant in the face of competition like that. Nvidia hasn't made any moves or said anything like, hey, we plan to disrupt the whole x86 ecosystem. But the fact that Apple can do it with, you know, what is largely souped up cell phone processors tells you a lot about how badly the desktop space has been languishing for so many years. Or, you know, if you want to be an AMD detractor, it's like AMD can come up with a competing product for Intel. What's wrong at Intel? I mean, that's not really fair. AMD's done a lot of work, and they're genuinely impressive products with a really clever out-of-the-box approach for what they're doing. And in a lot of ways, AMD's approach with Zen is a keep it simple, stupid approach with x86. And so you still get some of the x86 baggage, but not as much as you might think. And so the small silicon real estate and good processes and TSMC, and it all gets pretty crazy fast. And what I keep coming back to is, it's like Jensen bought ARM, Nvidia bought ARM, and Apple and Nvidia are kind of frenemies. And so does that mean that Tim Cook is going to buy TSMC? I mean, he could kill two birds with one stone. They could open up the TSMC America office in partnership with Apple, and maybe that would tick a few boxes in terms of like government regulations and international incidents and make everybody happy. We get some redundancy and international production capacity and some other things. I don't know. It'd be tough to make that work. TSMC probably doesn't want to sell, but Apple has a lot of money, and you know, depending on how uncomfortable Nvidia owning ARM is. I mean, Apple's got the license for ARM. I mean, Intel, like I said, Intel and AMD have licenses for ARM too. None of that's going to change. none of that's really going to go away. But, you know, Tim Cook's a supply chain guy, and it's like, ooh, Nvidia has bought ARM, and we need ARM for Apple Silicon. And we're having TSMC make Apple Silicon. We also had Samsung make Apple Silicon. We should buy TSMC, because they're not going to buy Samsung. Now, the real plot twist here is Intel and AMD teaming up to keep ARM out of the desktop, or Intel and AMD alternatively teaming up to build the best possible experience. We don't have, you know, a Project Athena where it's really just an excuse to exclude competitors from laptops. It's like, oh, the best experiences with all, you know, the same company. It's like, no, you need to focus on building the best darn laptops and desktops that you possibly can, no matter what the parts are. And that will keep people away from souped up Chromebooks or editing 4K videos on iPads, because that just seems wrong that editing a 4K video on an iPad is a genuinely good experience compared to, you know, editing it on a laptop. How insane is that? Anyway, I'm Wendell. This has been a Level 1 Ramble. I'm signing out, and I'll see you later.